Next, we are going to discuss about the various scheduling algorithms. The first scheduling algorithm is FCFS. It is a first come, first served scheduling algorithm. So, as I told, all the process that is ready for execution is available in the ready queue. The CPU scheduler picks any one process from the ready queue according to some criteria. So in this algorithm, the process that comes first that is scheduled first. This algorithm is called as first come first served scheduling algorithm. So the process that comes first and it is stored in the ready queue will be executed first. So we will see one example. So here in this example, you will be given the process and burst time. So what is burst time means amount of time it takes for execution. And here we have assumption. What is the assumption we have is the process are arriving in the order P1, P2 and P3 and all the processes are arriving at 0 milliseconds. So this is a Gantt chart for the CPU scheduler. So here we have process P1, the burst time is 24. So the process P1 is executing from 0 to 24. So here actually we have it will be executed from 0 to 24. So this is process 1. So next process is in the queue is P2. So the burst time for P2 is 3. So it will be executed from 25 to 27. So 0 to 24 the process P1 will be executed, then 25, 26 and 27 the process P2 will be executed. So P2 will be executed from 22 to 24 to 27. Then P3 will be executed from 27 to 30 because the burst time for P3 is also 3. So it is executed from 28, 29 and 30. So 3 it will be executing. So then we have a waiting time. How we can calculate the waiting time here is, so waiting time for P1. So here assume that the waiting time for P1 is it is not at all waiting. Once it is it is the first process that is selected from the ready queue. So the waiting time for P1 is 0. Then P2 actually it is waiting for 24 milliseconds because after the completion of P1 only P2 starts executing. So the waiting time for P2 is 24. Similarly for P3, so it is waiting at 27 milliseconds. So for P1 waiting time is 0 and P2 it is waiting for 24 milliseconds and P3 it is waiting for 27 milliseconds. So here it is average waiting. How we calculate the average waiting time is 0 plus 24 plus 7. So this is how we calculate the average waiting time. This is the average waiting time, 0 plus 24 plus 27 divided by 3. So average waiting time for this example is 17 milliseconds. So this is how we calculate the average waiting time for the first come first serve scheduling algorithm. So again here I am changing the order. So in the previous example the arrival time is arrival order is P1, P2, P3, but now I have changed the arrival order. So P2, P3 and P1. So P2 the burst time for P2 is 3 and burst time for P3 is also 3. So the P2 is executing from 0 to 3. 0 to 3 P2 will be executed because P2 is first in the queue, then P3. So again burst time for P3 is 3, 4, 5, 6 P3 will be executed. From 7 to 30 P1 is executing. So now the waiting time for all the process is now changed because the previous one arrival order is different, but now arrival order is different. So waiting time for P1 is 6 here. Okay, so how long the P1 is waiting is P1 waiting time for P1 is 6 because P2 is executing from 0 to 3 and P3 is executing from 4 to 6. So waiting time for P1 is 6. Then P2 is 0 because it is it comes first, so it is immediately executing. So P2 is 0. Then P3 it is 3. So now average waiting time is only 3 milliseconds. For the previous example, average waiting time is 17. But here average waiting time is only 3. Okay, so this is about the FCFS scheduling algorithm. So the next algorithm is shortest job first. So here the shortest job first is it is associated with each process the length of its next CPU burst. So whichever the process is having the smallest burst time, so that will be executing first. So this is about shortest job first scheduling algorithm. Here again, I will take the example. Here we have 4 process P1, P2, P3 and P4, and burst time is for P1 it is 6, P2 is 8, P3 is 7 and P4 is 3. So here which process is having the shortest burst time is P4. So the P4 is having the shortest burst time. So the P4 will be executing first. So next shortest burst time is P1. Next to P4 is P1. It is having the burst time of only 6 milliseconds. So P1 is executing from 4 to 9. So next shortest burst time is P3. So again P3 will be executing from 10 to 16. Then the final process is P2 because it is having the large burst time. So it is 8. So 17 to 24 P2 is executing. So now here how we calculate the waiting time is it is similar. So P1 is waiting for 3 milliseconds. So P1 what is the waiting time is P1 is waiting for only 3 milliseconds. P2 it is waiting for 16. So P2 is waiting for 16 milliseconds. Then P3 it is executing for 9 milliseconds. So P3 is waiting for 9 milliseconds. P4 it is not at all waiting, it is immediately executing because it is having the shortest burst time. So P4 is 0. So for P1 it is 3, P2 it is 16, P3 it is 9 and P4 is 0 because P1 here it is waiting for 3 millisecond, P2 it is waiting for 16 millisecond here, P3 it is waiting for 9 and P4 it is not waiting 0. So average waiting time is 7 milliseconds. So this is about the shortest job first scheduling algorithm. So these two algorithm comes under non-preemptive scheduling. Both FCFS, so that is first come first serve algorithm, as well as shortest job first scheduling algorithm comes under non-preemptive scheduling algorithm because the process CPU will be allocated next process only after the completion. Okay, this is about the shortest job first scheduling algorithm. So the next algorithm is shortest remaining time first. This is actually under the category of preemptive scheduling algorithm. It is not a non-preemptive scheduling algorithm. This is preemptive scheduling. So here shortest remaining time first algorithm. This is here again the process name, burst time is given. In addition to that, arrival time is also given for all the process. So for P1 arrival time is 0, P2 is arrival time is 1, P3 arrival time is 2 and P4 arrival time is 3. So according to this we have drawn this chart. This is about the shortest remaining time first algorithm. And the next algorithm is priority scheduling. So regarding the priority scheduling algorithm, for each process we have some priority number is associated. Unlike the previous algorithms, we have some priority number is associated with each process. So the CPU is allocated to the process with the highest priority. Whichever process is having the highest priority, so that CPU is allocated to that process. So priority scheduling, we have both the categories are available, preemptive as well as non-preemptive. So here in priority scheduling algorithm, we have the possibility of starvation problem. So what is meant by starvation problem is low priority process may never execute. Suppose if the higher priority process is having the long burst time, so then low priority process has to wait until the completion of the higher priority process. So this problem may occur. So this problem is called a starvation problem. So we can give the solution to the starvation problem. That solution is aging. So what is meant by aging means as time progresses, we can increase the priority of the process. So this is about the example. Here as I told, you will be given the process name, burst time as well as priority is also given. This is the important part in priority scheduling algorithm. Here we assume that the lowest number is having the higher priority and highest number is having the low priority. So one will be the priority, one will be executing first and the priority 5 will be executing last. So here P2. So P2 is higher priority. So the burst time is 1. So P2 is executing from 0 to 1. The next higher priority is 2. So 2 means here P5. So burst time is 5. So 2 to 6, the P5 is executing. Then next higher priority is 3. So 3 means the process is P1, burst time is 10. So it is executing from 7 to 16. So P1 is executing from 7 to 16. The next higher priority is P3. So burst time is 2, only 2. So it is 17 and 18, P3 is executing. Finally, the final process is 5, P4. P4 giga burst time is only 1. So again here it is similar, we calculate the waiting time. So for P1 it is waiting for 6 milliseconds. So P1 it is waiting for 6 milliseconds. P2 not at all waiting because this P2 is a high priority process. It is it never waiting, so it is 0. For P3 waiting time is 16 milliseconds. P4 it is 18 milliseconds, and P5 it is only 1 millisecond. So we calculate 0. For P1 it is 6, then P2 it is 0, and for P3 it is 16, and P4 it is 18, and P5 it is 1. This is 18. Okay, now when we add this P1 it is 6, 22, 40, 41. So 41 divided by 5 equal to 41 divided by 5, it will be 8.2 milliseconds. So this is how we calculate the average waiting time for the priority scheduling algorithm. So the final algorithm is round robin. So round robin, it comes under the preemptive scheduling algorithm. Here before the completion, that is once the time quantum expires, we will give the CPU to next process. So this is actually the example for the round robin. Again here there is no priorities needed here, only the process name and burst time, and here we have given the time quantum 4 milliseconds. So after 4 milliseconds expires, the CPU is allocated to the next process. So here for this on the Gantt chart is drawn here. So initially the process P1, so it is executing from 0 to 4. So once that time quantum expires, the CPU is allocated to the next process. So here we have remaining burst time. How many burst time we have remaining is 20 milliseconds. It is remaining. It is executed in next cycle. So next P2 is executing. So P2 is executing from 5 to 7. So even though the time quantum is 4 millisecond, P2's burst time is only 3. So after executing P2, the CPU will be allocated to the next process. It won't wait up to 8. So the CPU is allocated to the next process. So the next process again, it is only 3 millisecond. So it is executing from 8 to 10. So this is the first cycle. In second cycle again it will start from P1, P2, P3. Because of P2 and P3 is already completed its execution, only P1 alone is executing from 15 to 30. Sorry, 11 to 30, because we have only 4 millisecond is executed, so remaining 20 it is executing again, because we don't have any other process, so only P1 alone it is completing in 5 cycles. So this is about round robin scheduling algorithm. Thank you.